I've just recorded a quick little video about the about the fake Chinese blue pills that I came across. Well, I ordered 3 boards and 2 of them turned out to be fake. Like, have a look at the other video if you want to see how we program those. And now here we're going to be continuing where we left off. The last time. So we got the PWM working. And that's essentially all that we've done so far. So basically right now I just wanted to just to generate some sounds out of that. Just that so we can have a little bit of fun. Okay, so I want to be able to generate a tone on that pin. I have a little buzzer module. It's just stuff that you can get for the Arduino development. It's just a piezo speaker or piezo sounder, however you call it, with a itsy bitsy tiny transistor in here for switching. And it says at the back, I don't know, okay, I need a better camera if we want to do this professionally, but basically it's a low level trigger. So once the signal or the pin goes low, that will create some sound on it. So we have it right now configured as 1 kilohertz with the variable duty. We probably don't even need those timer weights in there. Well, not probably, we don't need those. Okay, so let's hook it up to the breadboard. So the ground is the white. So actually that should work no problem on 5 volts. In the setup that I have here. So right now it's powered from the dongle only, but I have a way to connect the power supply in here, whatever voltage I have available, and in here I have do I have some professional looking pointer or stuff that I can point with there? So this is the 3.3 volt voltage regulator that you can get for the Arduino board and stuff like that. So that powers mainly the dev board, and this is a old. Oh Jesus! This thing is old school 5 volts regulator, TS7805. It's very simple, you know. Pin 1 is the input, pin 3 is the output, pin 2 is the ground. Just hook it up and you have 5 volts that you can use for power stuff. Just put in a couple of caps just to smooth out the voltage. There are already caps on the 3.3 regulator because that came in a nice little package. So I'm actually going to add the external power supply on top of the dongle. No smoke, so we're good to go. So right now we have the PWM generating this 1 kilohertz signal. So I guess the duty will just control the loudness of it, I guess. But let's hook it up. So what do I have here? The white cable is the ground. There. The purple is the VCC. Okay, I have this horrible breadboard with the holes are all weared out. They're unusable, essentially. Oh, and there's music. This is some proper Jean-Michel Jarre stuff happening right now. Okay. Okay, and we can hear the decrease in a loudness. So the duty controls. Yeah, the duty cycle controls the loudness. Yeah. Okay. So we will want to make. So if we want to play music, that means generating different tones, and tones essentially they're just different frequencies. So how do we want to do this? So let's create a function where we can take in nodes. Yeah, we can take in let's say an array of nodes, and then we can just loop through this and play each of the tone associated with that frequency. What did I say? Let's play each of the frequencies associated with that tone. So play song. Play song, and we need notes. And the notes, well, writing a song using digits, that's like machine code for songs. So we need a slice of chars. Char. Yes. So that means that we can so for note in notes int iter, and then for each. Is that correct? Simply let's do this. And we don't need this, but we need to do a lookup. So we need an array of nodes and associated frequencies, and that's going to be char. Okay. And we need frequencies, which is a slice of integers. Yeah, I guess that'll do. So let's have a look at different frequencies. Frequencies. Something like that. This is in hertz, yeah. So I think this is the do, re, mi, fa stuff. Like this is this section of the notes, the C dur or whatever it's called. I don't remember. That's what we used in preschool when we were playing flutes and stuff. Yeah, so if we just go with this, well, from C to C, and we're going to skip the middle tones, or however they called, like the bem, I don't know what's the English name of those, the sharps. Like the sharp is like a little bit higher and whatever, I don't remember. I don't want to make a fool out of myself. Wait, okay, I guess that's what it is. So C, D, E, F, G, A, B, C. No way I remember that. So C, D, E, F, G. E, F, G, what is it? B, A, B, and then C. A, B, so capital. So that's what we're going to limit ourselves to. Okay. So maybe in that case we can just do it like that. Okay. Same. So, and then here we're going to keep the equivalent of the frequencies. So what was it? 263. No, 262, 293. 262, 293. 329, 349. 329, 349, and then 391 and 440. 392, 440. 49494 and 523. Constant never yeah. Okay, so once we iterate it, let's enumerate. So that means then we get the ID index, and so we have the play tone. Yeah, but actually we want to be able, because that only gives us a node, so we want to be able to take a length of the node. You know, like you have a node that's length is 1, it's half, quarter, like, and 1/8 of a node. So we need some sort of a beat. But I guess the beat has to be associated with the song itself. So if we're specifying a char in here for the notes, we also need a beat, which you know, I don't know what the English name of that is, but basically the length of the note that we're trying to play. I think. So actually, yeah, so we don't do this. We actually need a note and a beat. And then we need to calculate the direction of it. Yeah, the duration of it. So we have a play song, so we will need some sort of play tone, or yeah, and here we specify the single note. Oops, char. So that's where we specify the actual char. And in here we actually going to look up all of the nodes and take the associated, so we're going to look at the nodes here. We're going to find out what its index is, and then figure it out the frequency. So for here the index and then the node in so once we have this, so if node is equal to the we have a collision in here, so n. So if node is equal to n, we have to change the frequency. Okay, so that means that we need a struct for all of this. So tone, or however, so we need the reference, basically a lookup of nodes and frequencies. So yeah. And then frequencies. Okay, let's do it the long way. Well, actually we are on the embedded, so we cannot be that wasteful. We're going to use this later. Okay, so that means we need to impel it. So we will need the tone, the tones, the frequencies, and we need a handle to the channel that we're going to be driving. And that's where the interesting stuff begins, I guess, because we are going to be abstracting away over the embedded hull stuff. I guess let's just keep it simple for the time being. So what we're going to be doing is just taking the instance of this. Okay. So it's actually here, the PWM, and that's going to be PWM. Is it? Cannot find the scope. That comes from this dude. PWM. But that's going to miss all this generic stuff, yes. So that's going to be team 2. We basically need to copy this entire how you call it, this format from here. So partial remap, blah blah blah. Okay, but we're talking about the actual instances, so that's comes from the pack, the peripheral access crate, I guess. So this is the pack. Then we need the remap stuff, and we already have this imported. Then we need the channel and the pin itself. So the channel is C1 and the PA15. and those need to be in scope as well. So we find the channel in the PWM stuff, and we need the GPOA it's GPO, yes, GPOA, and then the PA15. Okay, this is already getting messy. Yes, of course, and that's the setup, which is the alternative. Let's double check. So I want to be able to get this working, and then probably we can try to abstract it, although I don't feel too good about this, because this is going to be the serious generic stuff over the embedded Hall crate. We'll see how we get on. So alternate push pull. Okay, so that's what we need to copy. Oh, holy Jesus. And then push pull, I guess. And those need to be in scope as well. There it is. Where do I find the alternate? In GPO and push pull, also in GPO. Oh, push pull. Okay, so that works. So when we are creating a new we are going to specify the PWM stuff. So the whole this. So that's going to be a type. I guess something like that. And that's PWM tone. I don't think this is the most unfortunate name, but I guess. So we need PWM. I guess it's fine to just move it in here. Okay, so then we need to initialize this stuff. So PWM nodes, I guess we just do it like that. And we need the frequencies. So we are specifying. Okay, so let's do this now. So if we catch the note, we are just going to set the frequency. What is it? PWM. PWM set frequency. That should be. No, we don't. Not frequency. It's called period. Okay, and the period is going to be. The period is going to be the frequencies, and at that index, because we know that this node corresponds to this frequency. And that's because those methods are implemented on the tone, so we need self as well, and we need reference to self, but that needs a mutable one. So that means that this also needs to be mutable. Why is this a problem? Oh, that's because it's the beat is going to be what we're specifying here, so it's a type, I guess. And then it's no longer notes, because now it's self notes. So it doesn't like the frequencies, and that's, yes, that's because it has to be this. Okay, and that's why it cannot be the U16. So this essentially comes from the embedded Hall crate as well, hertz, and that's no, not from the embedded hertz, from the STM32 crate. There. So that comes from the time module. Let's have a look at what's there. There it is. So what is it implemented on? So we can only use U32 anyway. Isn't that weird a little bit? Well, I guess it's implemented on a type that can. Okay, we will need to check. But anyway, this now works, except this. Well, I guess we can. Well, we don't need to move this. We can just take a reference to character. Okay. So now, yes. So we can just simply take in, and then just play the notes. But we need to be able now, because we have the beat, so we need to be able to calculate the duration of the. We need to be able to calculate the duration of the tone, and we're going to use the beat for it. So that means we need to be able to pass in some timer that we can use to calculate the duration. Okay, so how are we going to do this though? So we need a specific timer that we can pass into here. So we're using a static timer. So there was a we should be able to just specify a delay, but we need a timer for that as well. Okay, let's so delay, and that uses SysTick, and we are already using SysTick for the clock. So that's coming from the hole. Okay, so yeah, unused. Okay. Okay, so we're just passing the delay in here, and just accept the trait. So the D is the delay. What was it? Delay MS. Which we need to import from the embedded hole. Let's just make sure that delay embedded hole blocking delay MS. Okay. What was it? Blocking? Yeah. Delay. So okay, so we're not going to need this. Let's keep the timer or the LED running. We don't need this, we don't need this, we don't need this, we don't need this. So tone, new, and we need to pass in the PWM in there. And we need the delay. That's just a trait, but we need just a delay, yeah. Okay. So the delay, new. So it has to be SysTick. Configures the system timer SysTick as a delay provider. And then, so that means we won't be able to use this clock, because this takes ownership and that requires it as well. The clocks is fine because that's just a reference. So we can just take in the countdown timer. Because it's either this or this. Okay, let's do it the way I know it's going to work. And then we can try the other one later. Oh, the delay takes clocks by ownership as well. Does it have to? Don't know. Let's get something working and then we'll see. Oh, my peeps are coming in. Okay, I'm going to pause this for a second. Okay, back. Where were we? Okay. Okay, so yes, so it's either the SysTick timer or the delay, and we decided we're going to use the delay. Okay, that's not gonna work either because we're passing the PWM into the tone, so that's not needed. That's not gonna work either, so it's going to be delay MS. We had 1 second delay, yeah. Okay, so that kind of became a little bit uglier now. but let's see. Wrong number. So we need something way larger than that. So where are we? What's going on here? We need to explicitly say what sort of type we're passing in. And we have a syntax error. Okay, so now we have a warning that this is unused. Okay, but so now we should be able to calculate the duration of the tone. Yeah, the tone duration. So that's going to be beat times what? Because it cannot be the beat itself. It's like the tempo of the song. Because we can either have like 1, 2, 3, 4, or 8. That's the, or 16. This is the length of the tones. So it's a tempo. Yeah. So we're going to put it into here because it's just some U32, I guess. Yeah, and then we play the tone and we wait for it to finish. So delay ms, and then the tone duration. So it has to be mutable. So is this okay? Looks like we're back in business. So that means that this has to be mutable. And now we can tone play song. So we need to specify a song, and I just know the candidate. We're going to play a lullaby for the baby. Because I kinda know how to play this. G, E, E. Okay. So this is like the 2, 2, 2, 2, 2, 2, 4, 4, 1. 2, 2, 2. I think I'm not mixing this stuff up too. Okay, so const cut song, which is going to be array of char and u32. Does that work? And then we have 24 nodes in it. Okay, so GEE. No, it's not that. It's, and then the length, which is 2. Just okay. It's G, F, D, F, D, and then CG, CG. And that's the first one that was citizen G. Yeah. And that gives last note. Just this. Okay, and then those are force. And that's all. I think this is reversed. So this is going to be 1, 1, 2, 2, 2, 2, 2, 2. Because it's 2 easier. Because you're taking by tables are. Then take the false, and I just don't have false. So it's going to be simply just invert and make those actually invert. This is going to be 4, this is going to be 1, 1, but maybe get exceed, but not that. But it's more than enough for this. So this is actually going to be 4, and then 1, 1, and then this is 4 again, 1, 1. Invert, yes. Yeah, so it's 4, 1, 4, 1, 1, and this is 2, 2, 2. So 4, 1, 4, 1, 1, and then 2, 2, 2, and then we get to the CG. Just get 4, 1, 4, 1. Okay, aren't we using channel anywhere? So nodes is actually now going to be the cut song. that's... Oh, I'm moving this in here and it's a loop. So actually we can just make it borrow mode here. Aren't we? But we're not turning on the we need to turn on the PWM actually, because so we need to turn it on before we start playing the song, and then we just start adjusting the period. So enable, that's why we need a channel, and then we just disable. Okay, so let's hook up the and then okay, this is still the old one. Let's connect to it. In the moment of truth. Oh, that's probably because I'm extremely silly, because we forgot to build it. Yeah, because we don't need this, but we don't worry about this now. Okay, now is the moment of truth. Before one was a fake moment. It's not working. Let's go to main. We're gonna wait ages for this. So we have frequencies, we have delay, we have notes. Let's reset it. So the LED is flashing, so it means that the code in the loop gets executed. Let's have a look at the logic analyzer. Okay, need more light. So this and the gray. I'm going to stick in the buzzer and the logic analyzer together. And the pin is, oh, that's because we haven't specified the, we need to specify the duty. PWM dot set duty channel 1, and the duty is going to be self.pwm what is it, max get duty, get duty, no, get max duty. Yeah. And half a duty cycle is fine. That's because we don't have self. Not yet. Okay, so we need, do I need to specify it in here? No, I need to specify this in here. I need to build it. There. So we're a business. So the duty cycle is the same, but just the frequency changes. It's hard to see though on this screen. So we've reached our goal. This. So I guess this is a good place to finish it up, I think. So there's a couple of things that can be changed here straight away, and I think the biggest is that you probably don't want to use the PWM to do it. I think because there is this option, and what is it called? What is it? It's like a timer. Keep forgetting. This is the output compare, I think. So basically, you can, or is it? It's basically a way to configure a timer to drive external pin according to the, to the internal counter register. So I guess trigger input, trigger event, external trigger. I think that's what it is. So you can drive a pin, essentially. So we would need to have a look at how we do it. We don't need this, we don't need this, we don't need this. So we will need to have a look in here. Are there any examples? There's timers examples of that. Okay, I need to run because the baby is getting very, very anxious. Unruly, I don't know. She cries. Okay, bye bye.